Parabolas are conic sections.
Which are equations of curves such that any point within the curve is equidistant from a fixed point called the focus and a fixed line called the directrix. It is important to note that the focus is not on the fixed line. Many parabolas can be found in real life, and we can apply graphing or graphing softwares and parabolic solutions to solve for these real life parabolas, parabolic equations.
Have you ever thought about the curve of a Pringle chip? How about that of a banana? Well then, let us satiate your hunger for knowledge and educate you about the parabolas in these snacks.
Let's start simple. You will use the aforementioned Pringle chip as the first example. Pringles are usually stacked into each other into a tube, so it's a good design for it to be a hyperbolic paraboloid. The curves in its shape prevent a line of stress from forming to avoid the bottom Pringles to be crushed and stacked.
Let's try to find the parabola equation of this Pringle. Here you can see that we've already highlighted the parabola in this image with our vertex located in origin, and we can label our directrix or fixed line at y equals 0.28. In the list of equations, we can say that a equals 0.28, meaning that our focus is at 0, -28, equidistant and perpendicular to our vertex and the directrix. By substitution, we can see that our parabola has to be x squared equals -4 times 0.28y. And here is our solved parabola on the Pringle.
Okay, how about another food example? Bananas. They, aside from their bright yellow color and sweet taste, are typically recognizable for their crescent-like arcing figure. That figure is parabolic and it can be observed in bananas because they undergo negative geotropism. They grow upwards against the force of gravity. This does not mean that gravity has no effect on them though. Gravity still pulls on them, and that is what causes them to be curved the way that they are.
Let's try to get the parabola of the banana shown right now. If we upload this picture into a graphing software and center it to the origin, we find that the best fitting parabola is x squared equals -1.6y. Its directrix is the line x equals 0.4, while its focus is at the coordinates 0, -4. Other than food, parabolas can also be found in household items like pail. The picture shown now was taken in the girls' residence hall in PSHSMC. The handle is longer than the diameter of the pail opening, but since its ends are attached to the pail, it forms a curve possibly resembling a parabola.
If we upload this photo into a graphing software and try to find the parabola, the result would be this. The directrix is at y equals 0.28, and the focus is at 0 and -0.28. This makes the equation of the parabola x squared equals -4 times 0.6y.
Parabolas are all over the place. We won't go over them in detail, but here are a few more examples.
Dolphins form parabolas since they need to jump in and out of the water quickly to breathe oxygen while still remaining wet.
Suspension bridges are also shaped like parabolas for stability and safety.
Parabolas are also present in different monuments such as the bottom part of the Eiffel Tower for stability since it is symmetric and equidistant.
Dish antennas are also purposely made into a parabola shape to direct the waves to the receiver and its focal point.
Roller coasters also make use of the parabolic shape for a free fall thrill. Parentheses are just shaped like parabolas.
Some cabinet handles are parabolas for holding comfortability. Some bed frame designs are also parabolas for aesthetics.
In conclusion, parabolas are scattered all over our environment. We just need a keen eye to see them. Each of these parabolas have equivalent equations that we can find out through the virtue of graphing. We can apply graphing not just on parabolas, but to many shapes and structures we see in real life, to find out what their equivalent equation will be, how stretched or compressed these shapes are, and where the vertex and significant points would be. If you ever think about designing large bridges in the future, or simply just trying to look for the focus of your concave convex physics project.